Suppose that we're given 2 points that lie on the same line, and then we're asked to find the point that is in the middle between those 2 points. So in other words, what that means is that we gotta find some midpoint M that is at the same distance from A as it is from B. So basically it is going to be right in the middle of that line segment between A and B. Now you might think, okay, so what would be the best course of action in order to find that midpoint B? Midpoint M. And the best way to do it is to actually think about how you are actually distributing these points on the Cartesian plane. So for example, you have A over here, and then you have B somewhere over here. Now if you join those 2 points with a line segment and then you draw a point right in the middle of them, then what is going to happen is, if you draw a triangle, a right angle triangle here, that midpoint should actually be halfway along the horizontal axis and halfway along the vertical axis. So it turns out that this distance here, let's call it h, is going to be the same on both sides, and then this distance here, let's call it w for width, is going to be the same as well. So basically the distance that is diagonally is going to be the same. The horizontal distance between the point M from A and B is going to be the same, and the vertical distance is also going to be the same. And that's why in order to calculate M, we use the formula that is essentially just taking the average of those 2 points. So when you take an average, remember, so let's say you have 2 numbers, 1 and 4. Now you know that to take an average of 2 numbers or more numbers, all you need to do is you add them together, and then you're going to divide the result by the number of points or the number of values that you're putting into the equation. So in this case, the average would be 1 plus 4 divided by 2, which is 5 on 2, and that's 2.5. So basically, if you were to draw these 2 numbers on the number line, say 1 here, 4 over here, then you have 2 and 3, then the average would actually give you a point that is halfway between 1 and 4. So applying the same logic, we can say, okay, so if we're given the coordinates, horizontal coordinates of these 2 points, we have only 2, then how about we take the average by just adding those up and then dividing by 2. And we can do the same for the y coordinates, because we know that it's going to be halfway vertically as well. So we have y1 plus y2 divided by 2. And that's it. That's the equation of the midpoint. So all we need to do now is just plug in the values to find the coordinates of M. And with that, we can pretty much just get started on calculating midpoints. So let's say we want to find the midpoint between these 2 points. So the formula tells us that we just take an average of the points. So for example, x coordinate is 1 plus 4 here divided by 2. And then for the y coordinates, we have 0 plus 4 divided by 2. Now M is going to be 5 divided by 2. And then y is going to be 4 divided by 2. So we could write the midpoint as 2.5 and 2. And that's it. That's how you find the midpoint. So let's do some more examples on this. Find the midpoint of these 2 points. So we're going to have the formula x coordinates together plus 2 divided by 2. Then minus 2 plus 0 divided by 2. Now this is going to be minus 4 plus 2 is minus 2 divided by 2 is minus 1. And then we have minus 2 divided by 2 is minus 1. So that's going to be the midpoint between those 2. And one way you could check this is if you were to plot this on the Cartesian plane, say you have your x and y axis, then you would just plot the point. So you have minus 4 here, then minus 2, and then you have 2 and 0, so that would be somewhere over here, and then this point would be somewhere here, so minus 1, minus 1. And you can see that if you were to draw a line segment, this would actually be halfway between those 2 points. So that's one way you could check it very quickly, just by plotting the points on the Cartesian plane. Now we're gonna go with the next question. This one is a little bit harder because the coordinates are a little bit off the center, but doesn't matter because we know what the formula is. We just add the components together and divide by 2. Minus 16 minus 1, actually, yeah, because for now you're just adding them together, so it doesn't matter, they can be negative. Okay, so this is minus 7 plus 1 is minus 6 divided by 2, that's minus 3. And then we have minus 17 divided by 2. Well, we could just leave it as it is, or we could just convert it to a decimal. So minus 3, 17 divided by 2, that's going to be 8.5, so minus 8.5. And that's the midpoint. So you can see that in this case, the line segment is quite long because we're jumping from 1, minus 1 to minus 7 to minus 16. So obviously, we expect the point to have coordinates right in between those two. And now what we're going to do here is, so we're just going to go through here. And we're going to do the same thing here. So we're going to calculate the midpoint. Once again, we add the x coordinates, minus 4 plus 2. Divided by 2, minus 1 plus 3, divided by 2. It's going to be equal to the midpoint, so that's going to be minus 2 divided by 2 is minus 1. And then minus 1 plus 3, that's 2, divided by 2, that's 1. And we could try and check this one as well, just for, just to be sure that that's correct. So we have the point minus 4 here, and minus 1. That's the first one. The second one is 2, 3. And then we have the midpoint should be at minus 1. So somewhere here and 1. Yeah, and it does look, I mean, I haven't really used the ruler for this, so I don't really know exactly what it is. But it does look like it's halfway between them. So we can be satisfied that that's the correct answer. And that's it. That's how you find the midpoint between two other points.